So now we'll actually bring some calculus into it. For this problem, the instructions tell us to use partial fractions, but the question itself indicates that that's what we need to do right off the bat. We look at the degrees. They're off by 1, which on the quiz, you would have just said, okay, let's do use substitution, be done with it. But that's because we hadn't done partial fractions yet. The degrees are off by 1, but just as important, that denominator is factorable. That's a 2x plus 3 and a 2x minus 3. Because the denominator is factorable, that's what tells me to do partial fractions. You didn't see any of those on the quiz, but now they're fair game, but they're easily identifiable. If you can factor the denominator, or if I've already factored it for you, start with the algebra skill of partial fractions and then actually do the calculus to go with it. So, in order to get those two factors in the denominator, I must have had some constant over a 2x plus 3, some other constant over a 2x minus 3, and that needs to equal our original. Again, with those two factors underneath. And so from there, I'm going to try to write as little as possible here, kind of the minimum that I could get away with and still earn credit. A times 2x minus 3 in order to get the first denominator to look good. B with a 2x plus 3 to get the second denominator to look good needs to equal 8x plus 18. We've made the denominators equal, so I don't even need to write them anymore. I just need to match up the numerators. From here, you can do the Heaviside method, which is what I'm going to do. You could also do that coefficient trick that we did for our first example. The Heaviside method, you end up having to deal with some fractions. So if you want to avoid that, you could do the system of equations thing we did first, looking at the coefficients. But for me, I'm going to go ahead and say, to get this first piece to equal 0, I'm going to plug in x equals 3/2, because that's going to give me a times 0, plus b times 2 times 3/2 is 3, plus 3 is 6. That equals 8 times 3/2 plus 18. So I have 6b equals, what, 4, 12, plus 18 is 30. So I have b equals 5. Again, you could have avoided some of that fraction work with the other option, but then, other stuff ends up taking longer. So they work out to be about the same level of difficulty. For the second piece to equal 0, I'm going to substitute x equals negative 3/2. So a, that's negative 3 minus 3 is a negative 6. The b term becomes 0. That was the whole point of plugging in that x. 8 times negative 3/2 plus 18. So I have negative 6a, and then that's negative 12 plus 18, 6. So a is negative 1. And if I didn't mention it a minute ago, I will mention it here. And if I did, it bears repeating anyway. I would advise against skipping straight to this step. Because what ends up happening is that just, as you get into a problem, you forget where your a is supposed to go and where your b is supposed to go in the fraction. So here, just scribbling out this top piece just gives you a reminder of which constant goes where. So here I can see that my a goes over a 2x plus 3. Just rewrite that. So my negative 1 goes over a 2x plus 3. My b, this 5, goes over the 2x minus 3. We haven't done any calculus yet. All we've done is we have taken the original expression here, and we've rewritten it as the sum of two other expressions. We still need to integrate. But now that we've split these up with addition, I can integrate those two pieces separately. And they're much simpler quotients than what we were originally given. So, I'm going to do some mental use substitution, and then we'll talk a little bit about where that came from. But here, for the first one, I'm just going to treat that negative 1 as a constant multiple. So I have a negative 1. My degrees are off by 1, which tips me off to do use substitution. And again, I'm going to do mental use substitution. So my degrees are off by 1. U equals that whole denominator. So I have natural log absolute value 2x plus 3. But if I leave it like that, it's not right, because if I take the derivative of this, then an extra 2 is going to show up because of the chain rule. So to counteract that, I'll put a 1/2 in front. So that's the mental u substitution. We'll deal with the other fraction in just a moment. If we had actually written this out, and hopefully you'll get to the point that you don't have to write it out every time, but we let u equal 2x plus 3, dx was du over 2, and that denominator was where that 1/2 came from. For the second term, again, that constant multiple, I'm just going to bring that out front and worry about everything else. I have a natural log absolute value of this denominator. I'm using a different u than what I did over there. And here again, mental u substitution puts a 1/2 in front. And now we're plus c, and we're finished. Just a reminder that the mental u substitution, at least the way that I think about it, works best when your u prime is constant. If this had been a 2x squared minus 3, then that's a more complicated u substitution process, and I would still recommend writing it out. But here, u prime was constant, so we could bring out its reciprocal as a constant multiple here and over there. So our final answer, negative 1/2 times this natural log, positive 5/2 times that natural log, plus c. If you were to check this by taking derivatives, then first off, some of your u primes would cancel with those 1/2 that we put out front. And you would end up with these two separate rational expressions, and then some more algebra would get you back to the original rational expression, which we have enormously right there. So we're just doing that whole process backwards. Some algebra and then a little bit of calculus. In your flowchart, path G we filled out already. I'm going to go back to that, see if I can find it. Oh, there it is. So something we didn't deal with before, at least, well, we haven't dealt with it yet until today, was if the denominator is factorable. Up until this point, I haven't given you any factorable denominators. But now, that's something you need to check. If your denominator is factorable, it's automatically a partial fractions problem. So let's take a look at the examples that go with that one. This first one might not be immediately obvious as a partial fractions question. I notice that I can't do any long division because my denominator's degree is bigger. The degrees are off by 1, which might make you think u substitution, which was true on the quiz, but now you have to check just one more thing, which is just try to factor the denominator, if I haven't done that for you. So my 2x squared, 2x times an x, and then a 3 times 1, I'll put a 3 here, and a 1 there to make the 7. Since our denominator is factorable, we have to do partial fractions before we do anything else. U substitution, as far as I know, isn't going to do you much good here. So I need some constant over 2x plus 1 plus some other constant over x plus 3 to equal our original expression with those two factors as its denominator. Simplifying this a little bit, so I have a times x plus 3 and a b times 2x plus 1. That numerator on the left needs to equal the numerator on the right. Here again, I'm working with coefficients or doing the Heaviside method. Either one would work just fine. We did the previous one with Heaviside, so I'll do this one with the coefficients trick. It really doesn't matter. But if I'm going to do the coefficients trick, I have x coefficients and I have constants. My x, so if I distribute, my x is going to have an a from this first piece, and then it's also going to have a 2b from the second piece. And on the right-hand side, It has a 1. For my constants, from the first piece, I have a 3a after distribution. Second piece, I have a b after distribution. And in my result, I have an 8. Okay. So this system of equations is a little bit nastier than the one we did earlier, but still not too bad. I'm just going to take this first piece and leave it alone. And the second equation, I'm going to multiply everything by -2, so I can get some stuff to cancel. So -6a minus 2b equals -16. So -5a equals -15. A equals 3. And then you guys know how to solve systems, and if you don't, use the Heaviside method, I guess. But from that, once I have the a, I can substitute it to find the other unknown. 3 plus 2b equals 1. 2b is -2. So b is -1. This really is the harder part of this question, which isn't necessarily hard, it's just it takes longer than what we're about to do. Because what I have now is two separate and simpler quotients that I can integrate. My a goes over the 2x plus 1, so 3 over 2x plus 1. b goes over the x plus 3. And then, because they're separated by addition, everything works nicely. Just bring down the addition. Constant multiple of 3, just bring that out front. Natural log absolute value of 2x plus 1. Mental use substitution, it's a 1/2 in front. Over here, I'll bring out that -1. Natural log absolute value of x plus 3. Its derivative is just 1, so I don't really need to do anything about that. You could say there's a 1/1 in front. Of course, that doesn't make a difference. So we have 3/2 natural log absolute value 2x plus 1 minus natural log absolute value x plus 3. There it is. There's some stuff you can do with properties of logs to make this look different if it's a multiple choice question, but there's no need to do that in general. I'm about out of time on this video, so I'm going to pause and start a new one for the next example in the packet.